Hey everyone, I'm Ijemma, the creator of Nkọwa. In this video, I want to take a closer look at a technical blocker and setback that we were experiencing up to a year ago, specifically concerning the way that we were deploying our Firebase functions. This Google Groups forum post best describes the issue that we were running into, where we're hitting a function deployment limit error. This post specifically is talking about how they were getting this error when they were deploying 80 functions at one time. And even though we didn't have 80 functions at the time that we were experiencing the exact same issue, we were still experiencing the issue, and we had to start thinking of more clever ways on how to consistently deploy all of our cloud functions while preventing this error. On top of that, there are a lot of limitations that just exist within Firebase functions in general that you kind of don't run into with other backend framework options. So with all that, I'll walk through the solution that we took to avoid this error and then also add some extra benefits that don't come out of the box with Firebase functions. So this file right here is our index.ts file. I like to think of it as our main entry point to our backend service. So anytime that a request is made from our front end, like someone is attempting to suggest a new dialectical variation, they're trying to enroll in a new course, they're trying to save a new word, any actions, all those requests will be piped into index.ts, and the responsibility of this file is to figure out which cloud function needs to be executed in order for the expected or ideal response to be returned back to the client. So you can see in this file that we export a number of Firebase Cloud Functions. We have dictionary, instructor, learning, organization, and Stripe, and a lot more. This is very different from the way that we were writing our cloud functions up to a year ago, where we had 30, 40, or even 50 cloud functions all within this one file. But the solution that we took does two really nice things. One, it batch groups our functions, so we have things now called function groups, which is just a group of functions of business logic. And then the second benefit with our new solution is we're able to handle the concept of middleware. So any of our backend functions are able to take in a series of middleware steps to transform or prepare or validate the requests that are coming in. So to get a better idea of what I mean by this, we can take a closer look at this one cloud function, which is called dictionary. So to Firebase, this is just a cloud function called dictionary. But then inside our on-call callback, you can see that we're indexing into an object called dictionary functions. This is our function group, our dictionary functions group. In order for us to pick the right function to call, our UI has to specify what function needs to be called on the back end. So this is a parameter that comes from our front end, and then once we select which function to call, we then call it with the payload, the Firebase context, and then the function name as like a meta object if we need it again somewhere within our business logic. So we can take a closer look at what this dictionary functions object looks like. So here within our dictionary TS file, you can see that we export this object, which is containing 6 functions. They have the names of search word, get started word document, post word suggestion, and so on and so forth. If we take a closer look at any of these functions, you can see that we call this function called flowRequest, which returns a function. A lot of functions being returned and generated. In order for us to assign the value of a function to search word, for flowRequest, it has to take in 2 arguments. The first argument is an array of middleware callbacks or functions, and then the second argument is an optional options object. So it provides us more instructions on how flowRequest should act. So for this first argument, we have this array that takes in a function called handle search word. Handle search word is actually like a core business logic function. So all functions that actually execute some unique action are prefixed with handle. All of our other middleware is just called what they're supposed to be doing. So for this second example or second function, you can see that we have the authentication middleware that gets called before we actually call get start word. This is a legacy function which should have the prefix of handle get start word. In this example, you can see for post word suggestion, we authenticate the request, and then we validate the shape of the payload itself. And then if validation passes with flying colors, then we execute the business logic of actually creating that new word suggestion. And we follow that same pattern for all of our functions. So we can take a closer look at how flowRequest takes in this array of functions and then executes them in order. This file is probably by far my favorite just because it took a lot of clever thinking and trial and error, and it finally works consistently to the point where you kind of just are able to forget about it and it just consistently works. So we have this function called flowRequest, which takes in, again, our 2 arguments, where it's an array of functions, and then we have our options second argument. And what this flowRequest function returns is an asynchronous function where it's expecting the payload from the UI and then a context, which is our Firebase context, and then a meta object, which can have a series of different key value pairs. Inside of this function, we do a little prep work where we want to connect to our MongoDB database, and then we also want to connect to our Redis client, and then we want to place both of these newly created objects onto our meta object, which is going to be a consistent object passed between each step of our middleware. So what this means is if we're at any step within our middleware that needs to have access to our Redis client, it could just use the passed along meta object and then access Redis client and then request whatever cache data it's looking for. And the same concept applies to our consistent MongoDB connection. So we can make sure that for each request, we open just one MongoDB connection. So after that prep work, we get into really like the meat of this function where we are iterating through each of our functions inside of our functions array, and we're actually reducing it. So we're converting it from an array of functions into a chained promise. So our default value is just a resolved promise. So here chain is a promise. And then for this current chain, what we're doing is we're chaining a dot then, where we're calling our helper method handleNext function, which takes in the current function inside of our array, along with the default arguments, which includes our payload, context, and meta object. If any error occurs within us calling current function at this step, we also append this catch function in order for us to throw the specific error and then handle it accordingly. What's happening in handleNext function is something a little bit more specific to how we generate our meta object. So we're just doing another step of like pre-processing of our meta object. So we create this arguments object, and then with the correct arguments object's shape, we pass it into our current function and call it. And then we wait for the response of that current function and then get its results. If the result has an error code or just the code field living on it, that means an error was thrown inside of the function, and then we throw that error again one level up so we can handle it accordingly. But if the result object doesn't have any code field living on it, that means it passed, and then we can just return that result and then pass it along to the next step in our middleware chain. So again, at a high level, we're converting this functions array into a chain of promises that we can call step by step by step by step. So once we generate that chain of promises, we then want to close out of our MongoDB LearningDB connection, along with quit our connection from our Redis client. And then we return result. So with flowRequest returning result, that is going to actually return a promise to be executed when we call search word, and then we return that or place that inside of our object that gets exported from our function group. And then in this one TS file, we are now asking the UI when it's calling the dictionary cloud function to not only specify calling this function, but also specify the function name, because we need the function name in order to pick whether we want to execute the search word function, the get starred word document function, or any of these other options. And then once we specify the function name, we're given the actual function or business logic that we want to execute, which handles all the heavy lifting of handling the middleware and then performing the business logic and returning the final expected result. And we do that for all of our Firebase functions. So you can see that we do it also for Instructor. Our Instructor's function is probably the best example for why we needed to have this refactor. Because you can see here that we have more than dozens of unique functions that perform unique tasks. Like, for example, when we want to get a course, to get a course by an author, if we want to get a quiz, create a new quiz, update a new quiz, and things like that. We want to make sure that it's all clearly separated out. But if we didn't have it in this approach, and these were all their own unique Firebase Cloud functions, we would have hit that deployment limit error again. And you can see that each of our functions, again, use flowRequest. So we always want to authenticate the user. And then once we know that the user can view this course or is at least signed up, then we call our business logic of handle get course to get that specific course. So this refactor was way more involved than what I was originally expecting when this project was a lot smaller, but it was the best decision to make for our project at the time being, because we knew that in the future we would be scaling to such a size where we would need to be deploying a lot more functions in the future. So the solution is great for batching cloud functions. And then another benefit is that we're now able to handle the concept of middleware. So we can authenticate, authorize, validate the payload structure that's being provided over from the front end, and do all this nice middleware stuff before actually executing our final business logic function. One alternative was we could have listened for specific files that were related to Firebase functions, and then if we were able to detect that file A is attached to function A, we only deploy function A rather than the rest of our functions. But again, I wasn't able to figure that out, so this was our best next solution, which I think has been scaling very well, and we haven't noticed any performance hits because of this restructure. But this is a solution that we took to help scale our cloud functions. If you have any questions about why we did something like this or how one particular part of the code base works, please feel free to leave a question in the comment section below, and I'll be happy to answer any of your questions. And yeah, just wanted to walk through this problem. Thank you so much for watching this video, and I will see you guys in the next one.